critical factors for industry study for the timber products and furniture industry. In this section, we are looking for you to learn a little bit about tools, equipment, plant, the production processes. I sort of touched on these at the end of structural, mass production, mechanization, specialization. And by the end of it, we really need you to be able to identify what equipment processes and techniques are being used by businesses in the timber products and furniture industry. So let's get started. Tools and equipment. When we're looking at tools and equipment, you'll see the word plant there as well. Plant is another term. We're not talking about greenery. We're not talking about trees or grass or flowers or anything like that. Plant is any equipment that is usually permanently installed into a building. So if we think tools, typically we're talking portable. Equipment, typically we're talking stationary, but can be moved. Plant is usually equipment that is unable to be moved. Now, for example, if I was thinking about our timber workshops downstairs, we've got tools, so we've got the tenon saws, we've got the chisels, they're hand tools sitting in the cupboard. We then have equipment like the routers that can be moved around. We've also got a router table which can be moved around as well. But then when I'm talking plant, I've got a very large table saw which is installed into a specific position, cannot be moved. It's bolted down to the ground. I would consider that to be plant. They're all the same sorts of things, but we've just got to be aware what is being used in the industry. Now, you should be familiar with traditional tools, traditional equipment, traditional plant. So bandsaws, table saws, drop saws, sanders, any of these sorts of bits of equipment are fairly standard around the place. Things that are considered to be new or emerging, particularly areas that are in development or only have recently joined into the industry, are things like CAD, CAM and CNC. Now I say new and emerging, they've been around for a very long time, but by comparison to the other tools and equipment, they are considered still to be cutting edge. And there are always new versions and new developments coming along in each of these tools. But it's just be aware that the traditional tools where the human is in charge, the human operates them in a machine way, so the human holds a machine, makes a cut, and then the machine no longer works anymore. That's really considered to be old school machinery now. And so the new and emerging technology is a little bit more automated in the sense that the machine can do the work usually without the human's involvement. So the human might set it up and the human might supervise it, but the machine can mostly do the work on its own these days. So I'll go through them. We'll start with CAD. CAD stands for Computer Aided Design. This is where we're specifically talking about software on a computer that is being used to design different timber products, different pieces of furniture for our industry. SketchUp is a great example here. Vectorworks is another example. AutoCAD is another example. These are examples of computer software that aids the design process. The benefit of CAD software or computer aided design software is that it costs nothing to build something digitally. It just costs your time. So you're not having to build a prototype out of timber and then throwing a whole heap of materials away. Secondly, I can see CAM is there, Computer Aided Manufacturing. This is when the manufacturing processes are aided with the use of a computer. So this is where you're able to get your CAD design, export it from your computer into a piece of hardware, a piece of machinery, and then it is able to produce it for you. At this particular point, I'm probably thinking things like the 3D printers. They use the computer aided designs, the CAD drawings from SketchUp, to then manufacture a prototype with a plastic filament. Therefore, 3D printers an example of computer aided manufacturing. Do they use 3D printers in the timber industry? Absolutely they do. They use them to print small scaled prototypes of what the products might look like or what parts might look like so that they can show them to the client. The benefit of using these again is that it costs less. You can show it to the client and say, look, this is how it's going to work, and the client might say, I'm not happy with that, and you haven't wasted months or thousands of dollars worth of resources to produce the product to find out the customer doesn't actually like it. Next on the list there is CNC, computer numerically controlled. These are machines that use coordinate geometry, an X, Y, and a Z axes to basically do a whole heap of processes for us. And the best example that we talk about is the CNC router. Now, CNC router is a router that is controlled by a computer. The computer tells it how far forward to go, how far backwards to go, how far up and down to go, how far left and right to go. So they're your three axes, left and right, up, down, and backwards and forwards. Okay, the three axes. More advanced models have a fourth axis now, which is when they're able to then put a tilt in as well, so they can change angles. Again, what happens here is we get the file from the CAD software, we import it into the machine, and we program the file to say, use this cutting head on the router to make this piece of equipment, piece of timber, sorry. And the equipment, the CNC router, then cuts it precisely to size. Now, there are three other examples there, but I'm just going to talk about those three at the top. The benefits here, it costs less because there are less mistakes being made. You're not wasting timber because the machines here don't make mistakes with materials. The second thing to talk about is that all of these are changed from the traditional way work used to get done. Projects used to be sketched by hand on paper. Those people, they don't have jobs anymore unless they were retrained in how to use the CAD software. And then people used to cut their materials by hand controlling the machines. This is now done via computer-controlled machinery. And so those people aren't doing that same work anymore. But there's opportunities where they've been able to retrain and upskill in the industry. So there's been some change to the work that gets done, but the benefit is these machines do not call in sick. They can work 24 hours a day, 7 days a week. Doesn't cost any extra. The only bill there is the electricity costs. There is a negative though, and that's one of the costs, which is the cost of actually getting one of these machines. They can be in the thousands, tens of thousands, or millions, or even higher, depending on the quality of the machine and the size of the machine. So there's a very big investment that needs to be made in order to invest in these new and emerging technologies, and then there are long-term cost benefits on a project-by-project base with less mistakes being made and more production and more efficiency happening in the workshops. So let's talk mechanization. Let's be really clear about this. This is a syllabus term that you need to know a very clear definition distinctly from automation. Mechanization is when the human still does the work, but they are using a machine. The human is in control of the machine. The human is usually holding the machine while it's happening, okay? But it replaces hand tools. So instead of a tenon saw being used to cut, mechanization is where we're using things like drop saws and table saws. Okay? So there's still an element of the human being involved. The human is in control of the operation, but the human is still in control here. When the computer starts taking over the control of the machine and the human's not really making any control decisions, that's when we're looking a little bit more into the automation direction. Pros and cons of mechanization. Pros, obviously it's a little bit more accurate, you can be a little bit more consistent, it's a little bit faster. Again, the machines don't get tired, so think of how sore your arm gets when you're cutting with a tenon saw for a 1 hour lesson. Imagine if you're working an 8 hour day, and the machines don't really make mistakes or have accidents. The cons, they're obviously a little bit expensive, so a tenon saw might cost $50 from Bunnings. A good drop saw might cost anywhere from $200 up to $2,000. So there's a bit of a cost there, and then you need to train people on how to use them. Okay? When you've got these machines that are able to get more work done, you run the risk of losing jobs. So you might have people unemployed because you don't need them to do all the cutting by hand anymore. You now have an additional cost of maintaining the machinery, getting the blades sharpened, changing blades, greasing, oiling, all of those sorts of machinery maintenance that we do. And the last con there is if there's no electricity, these don't work. We're going to skip specialization, generalization, come back to that. I'm just going to move straight to automation here. Automation, hand processes are gone, and the human is no longer in control of the machine. Instead, the human programs the machine to do it automatically. Okay? The idea here is that you do not have the human touching the machine or the product, which therefore means the human is less likely to get injured. There's an increase in manufacturing speed, an increase in accuracy, an increase in efficiency. There's less waste, but less employees are needed. So there's a loss of jobs happening there. The disadvantages are obviously the jobs being lost, but also it costs a huge amount of money to invest in these machines, and it takes time to train employers on how to use them and how to maintain them. Both mechanization and automation are used in mass production. Okay? Automation is obviously more efficient and more productive, but both of them are used for mass production processes. Automation, okay, you can see there, the workers are away from the hazard, so there's less chance of workplace injury because the machine isn't near the human. Okay, nice and simple there. One of the big things that we talk about here in terms of how the jobs have changed, the human that has lost their job might need to be retrained, but instead of being trained in how to be a woodworker in terms of cutting, machining timber and sanding and finishing, instead now they're being trained in computing, electronics, maintenance, and how to program and code the programs that actually run each of the different parts of the process. So I'll go back now and start talking about specialization and generalization. Sorry for jumping around a little bit. Specialization, one person really skilled in one specific area, they're a specialist. So if I'm really, really skilled in making furniture, and that's all that I do in my life, and it's the only thing that I'm really good at, then I would be a specialist. But if I'm good at both computing, and I'm good at woodworking, and I'm good at riding a bike, and I'm good at swimming, but I'm not an expert in any area, I'm good at them, but I'm not an expert, then I would be considered to be a generalist, okay? Or a diversifist, okay? This is the opposite of a specialization. Instead of having one area that I'm an expert in, I have multiple areas that I'm skilled in, but not super expert in. You can also have a lot of good skills and then be a specialist in one particular area, okay? That's definitely something that can happen as well. Now, in the workforce, what this means is you might have someone working at Cooper's Furniture and their job is just to sand and finish projects. They would be considered a specialist. However, when you've got Vaughan, the boss of the company, who is able to do marketing, sales, design, cutting the timber, joining the timber, glue-ups, machining, sanding, finishing, if he can do all of those, he's a bit of a generalist. But if his area of expertise is in drawing the designs, then he might be a generalist in all areas of furniture making, but a specialist in design. Okay, so you can see there how you can have some people work in your company that are specialists, some people that are generalists. Now, we spoke about mass production in the structural area. Mass production is when you are producing the same item in a large volume. Think IKEA furniture. Think mega factories on Foxtel. If you're producing things in mass production, then you are usually able to lower the cost of each individual item, and you're usually decreasing the amount of time to produce each item. You usually don't need as many skilled employees because the machines are able to take over a whole heap of the work there because there's a high amount of automation happening. The opposite of that would be considered a cottage industry or a ma and pa business. These are small sole trader businesses. They make one-off products. We sometimes refer to them as bespoke furniture makers. Bespoke is a bit of an on-trend word at the moment, and it's where you make an individual custom piece of furniture for every individual client that comes in. It costs a lot more to run those sorts of businesses because you can't mass produce parts. But you can use some parts consistently, so you can use small elements in your projects, even if they're custom, that have been mass produced to try and bring the cost down. When you're mass producing, the way to make this really work for you is you need to get the manufacturing process and break it into small parts. You divide the labor up, so you divide your people to work on one individual part each and get them to become specialists in that area. And they repeat that process over and over and over and over and over. That increases the quality because they work out how to do it in the best quality. It also increases efficiency and productivity because they will inevitably work out the fastest and most efficient way to get the product made and to get the parts made. One thing that companies like IKEA are really good at is standardization of parts as well. So the example that I'll give here is I can go and buy a bed from Officeworks. Let me correct that, IKEA. I can go and buy a bed from IKEA and they've got 20 different models. They all look very different from the outside, but structurally they all use the same parts underneath. There's a metal frame, like a little skeleton and spine that holds the mattress in place. The timber on the outside is individual, but the skeleton structure that holds the weight of the mattress is common across every single bed. That's a standardization. It means that no matter which model of bed you get, you still go and get the same structural beams. The benefit of standardizing parts like that is you can produce them in an even larger quantity. So they're already mass producing these beds, but they can mass produce those standard parts so that they can use them across a wider range of products. That makes them even cheaper and even more efficient. The other thing that we do in mass production processes is we develop machinery that can perform some of those standardized tasks. So if we think of manufacturing processes, some companies you might have seen videos, production lines of boxes being folded. Rather than have a human sitting there and just folding boxes day in, day out, think of how boring that would be for starters. But there's machines that can definitely do that. So machinery is developed and brought in to take away the human from those sorts of repetitive processes, so the humans can be a little bit more creative in the workforce and working elsewhere where there's a little bit more creativity needed. When we talk about the development of machinery for standardized tasks as well, we might be thinking about, in a furniture making business, some sort of machine that is able to apply a nice, even and consistent finish, and that might be a spray booth that can apply sprayed finishes to a timber product. Okay? Where the machine might bring the product in on a conveyor belt, shut the doors, spray them 360 degrees, pass them out on the conveyor belt, and that machinery is just performing a very standardized task so that every product ends up looking the same. The real benefit to mass production is the reduction in cost, and the way that companies need to do that is they need to start off with the humans do the work, then they integrate small bits of machinery, but the machines and the humans need to work together in a very seamless manner. Now, if I'm talking about the Hind Timber Mill, you've had a look at their video virtual tour. Have a look back to the Green Mill video. There is a fantastic section there where you can see the machine has basically taken over all of the standardized processes. Measuring, scanning, labeling, sorting, stacking, all of those standard processes are done by the machines in an automated way. The humans are just there overseeing things and looking for anomalies that happen. So that's how mass production works in a really good example. I've got an example here of a mass production video. I'm not going to play the whole thing, I'll just put the link in, but you can see here the machine. Imagine a human doing this. It's the same thing over and over. They're just putting little blocks in the corners that can be glued to give this some structural support. Very repetitive process, very boring for a human. Anyone that would have that job would be very bored and dissatisfied with their job. So getting the machine involved here obviously is able to help and make a very big difference. Alright, so that's the end of the technical section. You can see again I've got some sample HC questions. I strongly recommend you look at the one in the box there, evaluating the effect of new and emerging technologies on work practices. When you're responding to that question, I really want you to write down in your introduction paragraph some of the new and emerging tech that's being used, and in each individual paragraph talk about how it has changed the work that is being done in the timber products and furniture industry. Use examples of companies, use examples of machinery, and use example of the work that's changed as a result of that machinery. Thanks very much, and look forward to seeing you for our next video on environmental factors.